Hello students, welcome back to today's class on quadrilaterals. In the previous classes we learned what are triangles or three-sided polygons, and now we are going to discuss about the four-sided polygons that are quadrilaterals. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So first of all, let's try to see what is a quadrilateral, which type of shapes or which type of figures we consider as a quadrilateral. Okay, you can see here. A quadrilateral is a simple closed figure, simply polygon. Okay, simple closed figure, we say that is a polygon. If you can remember the definition of polygon, a simple closed figure, right? Bounded by four line segments in a plane. How many? Four line segments. And now here you need to understand the difference between different polygons. In the previous classes, we discussed about triangle, which is a three-sided polygon, 1, 2, 3, which is surrounded or bounded by three line segments. And now we're discussing about a polygon with a four-sided, right? So how to structure that, how that quadrilateral will look like. So we have different structures. Triangle, we always have a triangle in this way, okay, based on the side lengths or whatever it is. We say isosceles triangle, equilateral triangle, scalene triangle, and based on the angles also we keep different names for that, right? Equilateral triangle and obtuse, acute angle, right angle triangle. So different names for that. In the same way, based on the different properties the sides have or the angles have, we name them into different structures. Although all these figures are again a closed figures of four segments by four line segments. Okay, so you can see here, if let's say all the sides are equal in this figure, so we say that square. If only opposite sides are equal, we say that as a parallelogram, right? And again, opposite sides are parallel, and these two sides are equal. So based on the different orientation, different properties that sides exhibits or the angles exhibits, we keep different names for them. And again, whenever we see different figures, sometimes all the sides of that figure may be equal, sometimes may not be. All the angles may be equal, sometimes may not be. Sometimes only opposite angles may be equal, opposite sides are equal. Sometimes nothing will be equal. No side, no angle, nothing will be equal. So based on that, we have different quadrilaterals. Okay, let's try to understand one after that in today's class. We're going to learn what are the different types of quadrilaterals that we are having. Okay, so the first one we're going to discuss about a rectangle. This shape, whatever you're seeing here, okay, the quadrilateral ABCD has four sides. First of all, let's try to understand about some terminology of this quadrilateral. Quadrilateral means a four-sided closed structure or four-sided polygon. The quadrilateral ABCD has four sides: AB, BC, CD and EA. AB, BC, CD and EA. So we have four sides. These four sides are common for all the quadrilaterals. If a quadrilateral is not having four sides, it is not a quadrilateral, it is some other figure. If it is having three sides, we say triangle. 5 sides, pentagon. 6 sides, hexagon. So we have different names for all those. Okay. So now, the quadrilateral ABCD has four sides: AB, BC, CD and EA. AB, BC, CD and EA, and four vertices. What do you mean by vertices? That exact corner points. This corner point, which we write it as A, this is B, this is C, and this is D. These are the four vertices. So a quadrilateral will have four sides, four vertices, and also if you can observe, there is an angle here, there is an angle here, there is an angle here, right? Whatever the angle it is, so we have four angles as well. So for a quadrilateral, we have four sides, correct? Four vertices, again that's correct, as well as four angles, So all these will be in count of four for a quadrilateral. Angle, this is how we represent angle, right? So this is angle A. The measurement here that we obtained is angle B. How to measure the angles, how to write them, that we are going to learn later. Okay, so these are the four angles. Angle A, angle B, angle C, and angle D are the four angles formed at the vertices. Angles will form at the vertex. at the vertices. Okay, so we have 4 vertices, 4 sides, 4 angles, and that type of structure we say it is a quadrilateral. Okay, so the next one, when we join the opposite vertices AC and BD. So this is a quadrilateral, you know that. Now I want to join A and C. So we get one line segment here. Let me draw that once again properly. So now we are joining A and C, not A and B, A and C, as well as B and D. So what is this BD? What is this AC called? AC line and AC line segment and BD line segments are called diagonals of a quadrilateral. Okay, so AC and BD are the 2 diagonals of the quadrilateral ABCD. Now the question is, for a quadrilateral, how many diagonals are possible? For a quadrilateral, 1, 2, 3, 4. No, only 2. Which 2? AC and BD. AC or CA, both the same. Again, no need to write it as 2 different diagonals. They are line segments. So again, BD or DA, again that is a line segment. So total we have 2 line segments. Total we have 2 line segments, 2 diagonals. So in a quadrilateral, when we said 4 sides, 4 vertices, 4 angles, but not 4 diagonals, we only have 2 diagonals. And again, based on the properties the diagonals exhibit, whether they are equal or not, whether they bisect. Bisect means they divide them into 2 equal parts, both the diagonals. Okay, so based on that also we define a lot of quadrilaterals. Okay, let's try to understand more about this one. Sum of 4 angles of a quadrilateral 360 or 4 right angles. Okay, this is always correct. Sum of 4 angles of a quadrilateral. So what are the 4 angles here? A, B, C, right? So angle A plus angle B plus angle C plus angle D. Sum of all these angles is 360 degrees. Sum of all these angles is 360 degrees, or